This is the solution video for question 10 from paper 2 of the 2019 TMUA or CTMUA exam. In this question we're introduced to a quadrilateral with vertices P, Q, R and S, with those vertices labelled anti-clockwise, and we're asked for which of the following, which we'll see in a second, is a necessary but not sufficient condition for PQRS to be a parallelogram. Then we're given 4 different statements relating the lengths of sides and if various sides are parallel to each other. So we need to make a choice to look at necessary or sufficient first. So we'll look at necessary because it seems slightly easier. So what does it mean for a condition to be necessary? Well, we need that if we've got a parallelogram, PQR or PQRS, A, B, C or D correspondingly is true. So looking at necessary, let's draw a parallelogram here and label the sides anti-clockwise. So PQRS. And we'll check our conditions and see if these have to be true in this parallelogram. So A, PQ is equal to SR. Yep, that's a key feature of parallelogram. And PS is parallel to QR. Yep, the opposite sides are parallel in a parallelogram. So A is necessary. If we've got a parallelogram, A must be true, so A is a necessary condition. Similarly for B, PQ is SR, we know is true, and PQ is parallel to SR, well, opposite sides are parallel in a parallelogram, so B is necessary as well. Now C, PQ equal to QR equal to SR equal to PS, all sides the same length. Well, from our arbitrary drawing, it clearly isn't true, but if we think about it, when this is true, we have a rhombus. Not all parallelograms are rhombuses, so C is certainly not necessary because C doesn't have to be true. And D, PR equals QS. Well, the vertical distance between P and R is the same as the vertical distance between Q and S, but horizontally, P is much further from R than Q is from S. Or we can just simply see graphically, PR is much longer than QS. These are not necessarily the same length for a given parallelogram, so D is not necessary. So given we're asked to find a condition which is necessary but not sufficient, it means for the sufficient stage we don't have to look at C and D, we just need to consider A and B as possible sufficient conditions. So now let's look at sufficiency. So let's start with A. So if A was not sufficient, what would we have? Well, we'd have PQ equals SR and PS is parallel to QR, so we'd have condition A, but we'd have it not being a parallelogram. So here's an arbitrary quadrilateral to keep track of what this means. So PQ equals SR means some pair of opposite sides have the same length and the other pair of opposite sides are parallel. So how do we build a counterexample? Well, let's try and construct one from first principles. So PS parallel to QR. So what we essentially need for it to not to be a parallelogram is PS and QR to be different lengths. So let's just construct them vertically like this. And we see that if the centre of this line is on the same vertical level as this line, if we draw these two lines, RS and QP are the same length, and we know our vertical lines here are parallel. So we know this shape satisfies condition A, but it certainly isn't a parallelogram. And so we know A is not a sufficient condition. And so we could conclude our answer is A, but to justify all our logic, we're going to check that B is actually sufficient. So now let's suppose we've got B. PQ is equal to SR and PQ is parallel to SR. So we know PQ and SR are essentially identical in nearly every way. They're parallel and have the same length. So let's draw PQ and SR and try and fill in the gaps. So we might as well, without loss of any generality, make RS, our line, a horizontal line. So we know PQ has to be parallel to it and the same length. So we could put it anywhere really, but let's put it here. And now we can see that we're nearly at a parallelogram, since if we join up P and S here and Q and R here, These are certainly the same length because P, Q and RS are horizontal in the same length, and they're certainly parallel due to the similarity of P, Q and R and S. We can visually see this, but even without rigorous justification, we're happy at least that B should be a sufficient condition. And so we've double checked and we can conclude that our answer is A.